I'm going to show you how to test a small signal transistor on a Heathkit IT121. We're going to test a 2SC945. The first step is to go to the datasheet and get some information. Here's the datasheet for a 2SC945. We can see that the pinout is ECB, so we can hook up our test leads to the device. If we look down below, we will note that the beta group of P, there is a P on the case of the device. We're looking at a beta anywhere from 200 to 400. Now that we know from the datasheet that our pinout of the 2SC945 is ECB, we can hook up our transistor to the test leads. Red is for the emitter, white is for the base, black is for the collector. Take note, I have made new test leads using Pomona mini grabbers. These are essentially the best mini grabbers on the market. They fit into tight spots. They easily grab onto tightly spaced pinout devices, and it's easy to get these mini grabbers to grab onto a device that's in a unit. For example, a radio, stereo receiver, etc. The steps for setting up the tester is that we kind of want to go left to right. We set beta equals infinity. We set the range switch to 10 milliamps. We set the transistor mode to the transistor versus FET, be in the transistor mode. And we want to select the setting for the NPN transistor type, which is this button should be in the out position. And then we turn the unit on. Now we do our beta equals infinity adjustment by adjusting our set beta knob right here. I can show you the movement. It's already almost adjusted. So we set the needle right at the infinity mark. Next step is we push the beta cal switch in, and we do our beta cal adjustment. Beta cal is essentially our multiplier, and for small signal transistors we want to be on cal times 10. So we adjust our cal knob to get into that black box, and now we are ready to test our transistor. We press in beta, which is gain for a transistor, and we land on 30. But we've got a multiplier here, cal times 10, so 10 times 30 equals 300, which is within the range of our predicted beta for a 2SC945, which was anywhere from 200 to 400. Testing FETs is very similar. Once you get used to this tester, it's quite easy. And you get an idea of the condition of a transistor from both the quantitative data, which is our beta of 300, and also you're going to be able to pick up a little, I'll call it qualitative data. By that I mean after you use the tester for quite a while, you'll get experience with the tester, and you'll be able to see differences in the speed of the meter movement. A bad transistor, a flaky, wonky transistor, might make the needle move around a little bit when it's landed at its test position. So experience and time with a unit will show you more data than just the raw beta of 300.